Welcome to another edition of ProSoft Technology video training. If you're having communication problems on your Modbus network, Modbus command exception or error codes are the quickest way to diagnose and solve the issue. In this video, we'll be going over some of the more common Modbus error codes, what they mean, and what you should check for if you get them. This is intended as a supplement for our lineup of product training videos that walk you through the full configuration process. First, let's go over the different kinds of error codes that we'll be dealing with. There are the Standard Modbus Protocol Errors, of which we'll cover 2, 3, 10, and 11. These can apply to any of our Modbus modules. We'll cover a couple of Modbus communication error codes, -11 and 255. These will only apply to our Modbus serial devices. Finally, we'll go over error code -48, which is a command list entry code, and -36 and -37, which are client-specific error codes. These only apply to our Modbus TCP/IP devices. Let's begin. Modbus Protocol Error Code 2 refers to an illegal data address, and this would be the address in the end device, just to be clear. Typically, an error 2 comes up when you're reading or writing an invalid data type or registers without a valid data point. For example, if you're reading a block of registers, but there is at least one register that's not available, that would throw an error 2 for that command. You can test for this by changing the register count to 1 to see if the error clears. If so, then the solution would be to adjust your register count to ensure that you're only reading and writing to those addresses that are available. This may mean creating 2 or more commands to read and write registers up to the gap where registers are not available, and then pick up reading the registers after the gap. Error code 3 is an illegal data value. This only applies to write commands, and it usually has to do with the Modbus device only being set up to handle a value within a certain range, and your command is trying to write beyond that range. An example would be trying to write an improper data type. For instance, if you have a device that is expecting a 32-bit floating point value, but your command only writes a single 16-bit word, the device will only receive half of the value. In this instance, you would first need to check that you are writing to the proper address in the device, and then make sure that you are writing the correct data type. In the example, this would mean writing 2 16-bit registers to encompass the one float value. Error code 10 and 11 are both specialized for cases where a gateway is involved, usually for the purpose of having Modbus RTU devices communicate with Modbus TCP devices. They're fairly self-explanatory. Error code 10 indicates that the gateway was unable to find a communication path from our module to the target device, and error code 11 indicates that no response was obtained from the target device. In both cases, the problem lies with the gateway that you're going through. It's either preventing our communications from reaching the end device, or it's preventing the end device's response from reaching us. Typically, the gateway is either misconfigured or overloaded. Moving on to the module communication error codes, we have code -11, which means the command timed out waiting for a response after a request. This is a very common one, and it's caused by one or more of a few different issues. First, check that the node address of the end device is correct. Then, be sure that your Comm settings, the baud rate, parity, and stop bits all match the network setting. Next, you should check your wiring. Are you using RS-232 or RS-485? If you're using RS-485, be sure that your wiring isn't backwards. You must also ensure that the jumper on the module circuit board is set to the proper wiring standard. By default, it's set to RS-232. You should note that for RS-485, the 5th pin connection is for the signal common. It's not a ground. If you try to use it as a ground, it will induce noise on your line. And finally, you should ensure that the response timeout on the module is set no lower than 1000 milliseconds, or 1 second. Anything lower and communications may not be able to keep up consistently. Moving on, we come to error code 255. which indicates an invalid CRC/LRC value in a response. This is usually the result of noise on the transmission line or the connection being closed while the response was still being transmitted. Again, check your wiring and be sure that the response timeout is not less than 1 second. The command list entry error code -48 indicates an error during ARP operation. This means the module cannot establish communication with the end device and suggests a problem with the physical layer of the connection. We like to use a phone analogy for some of these codes. A -48 is like you're trying to call someone to get some information, but when you dial their number, you get an automated response that your call cannot be completed as dialed. Maybe you have the wrong number, or maybe their phone line has been turned off. All you know is that the call cannot go through. For this type of error, you should first ensure that you have a good connection to the end device with nothing unplugged. Once you've ruled that out, the leading cause of the error is the communication path going through a managed switch that prevents our module from reaching the end device. For testing purposes, try to make a direct connection from the module to the target device. If that's not an option, you can try going through an unmanaged switch. If you're able to establish communication, then you know that you need to configure your managed switch. As for the client-specific errors, we have code -36, which means a client command response timeout. This is the equivalent of the -11 code for serial devices. To go back to the phone analogy, it's as if you managed to call the person that you wanted to talk to, and they've answered the call and you're conversing with them, but suddenly they just stop talking. The line isn't dead, there's no dial tone, you know the person is still on the line, but they just aren't replying to anything that you say. This error typically comes up when there is some kind of Modbus TCP converter being used to enable communication between Modbus RTU and TCP devices. The process can slow down communication and cause the message to miss the response timeout window. The solution is to increase the response timeout. Also, even though we're using Modbus TCP, some devices still use a slave address. Getting that address wrong will also cause an error -36. Finally, we have code -37. The TCP IP connection ended before the session finished. This is as if you were talking to the person and then, right in the middle of saying something, they suddenly hung up on you. For this code, you should definitely check the firewall settings on the PC to ensure our module is not being restricted. You can also check the timeout settings on the end device, as it might be stopping itself from responding. One last tip that has nothing to do with any particular error codes, but could be useful nonetheless if you're using Modbus TCP IP. Whenever possible, you should always designate a new client connection for each server device that you're connecting to. The MVI 56E MNetC module, for instance, has 30 client connections available. If you had 6 devices you wanted to communicate with, you would use 6 of those clients, 1 for each device. So while you can connect to multiple devices on a single client, it can lead to communication problems. Those are the most common error codes we hear about and the most common solutions. We hope that you found this video helpful. If you do find that you need assistance, contact our technical support. And if you're unfamiliar with any of the Modbus terminology or topics like function codes or Modbus data addressing, we also have a training video that covers the basics of understanding the Modbus protocol that might be helpful. Thanks for watching.